Hey everyone, if you're trying to figure out how AI agents actually run, how they manage their tools, and how you can scale them up securely without completely rewriting your software, you are in the perfect place. Okay, let's dive into this explainer on the AgentScope 2.0 workspace. Think of this as the absolute ultimate execution environment for your AI agents.
Here is our blueprint for today. We're going to meet the agent workspace, look at execution backend options, check out the agent integration interface, talk about managing multi-tenant deployments, and finally, wrap up with the MCP gateway solution. Basically, we're mapping a journey from a single agent's isolated local setup all the way up to a secure multi-tenant deployment. Let's get right to it.
Section 1. Meet the agent workspace. So what exactly is a workspace, right? Well, it's defined as the execution environment that supplies tools, skills, and context, offloading, and it inherently owns the life cycle of all those resources. I want you to ground this in a physical metaphor. Imagine a highly secure office building. When your AI agent essentially clocks in to work, the workspace is the environment that securely provisions absolutely everything that agent needs. We're talking its desk, its software, its internet connection, and when the agent is done with its task, the workspace acts just like a facility manager, turning off the lights, locking the doors, and cleaning up the resources.
Now, inside this metaphorical office, the workspace owns three very specific categories of resources. First up, we've got tools. This includes both your built-in tools and any Model Context Protocol, or MCP servers. Second, we have skills, which are dynamically added capabilities. And third, context offloaded. And honestly, why this matters is absolutely crucial for efficiency. Let's say your agent generates this massive data file, or maybe it has a ridiculously long conversation history. Keeping all of that in active memory, it's incredibly slow and super expensive. So instead, the workspace offloads those compressed messages and oversized files into a physical filing cabinet, returning just a tiny reference pointer back to the agent. This saves a massive amount of memory and keeps your agent incredibly fast.
Moving on to Section 2, the 3 execution backend options.
Now, what's really interesting here is how the exact same agent code can run across 3 vastly different persistence models, literally without changing a single line of logic. First, you can use the LocalWorkspace for direct host storage, persisting state right there in a local working directory. Or you could switch to the DockerWorkspace for secure containerized bind mounts. And for your cloud-based setups, there's the E2B Workspace, which manages your file system entirely in the cloud using a unique workspace ID. The beauty of this is total flexibility. You can test locally, you can containerize for your servers, and you can deploy to the cloud, all while using the exact same agent architecture. It's a real game changer.
Okay, Section 3, the Agent Integration Interface.
So what is the secret to keeping agent code so clean across all those different backends? It all comes down to a unified structure, the workspace-based interface, and it handles 4 really crucial roles. First, it manages the lifecycle, initializing, closing, or resetting things to provision and clear state. Second is discovery, which lets the agent automatically enumerate available tools and skills. Third, it standardizes that offloading for the compressed context we talked about earlier. And fourth, it handles dynamic management. This means you can register or remove MCPs and skills completely on the fly. This structural consistency is really what makes the whole framework so powerful.
And here we can see exactly how this integration happens along 2 main axes. On axis 1, we've got resources. The Agents Toolkit automatically ingests the built-in tools, MCPs, and skills. Actually, quick pro tip straight from the documentation, if your agent has an overwhelming number of tools, you can partition them into tool groups. The agent can then just activate these groups on demand using a built-in meta tool called Reset Tools. That way, it doesn't get overwhelmed. Then on axis 2, we have offloading. Rather than dealing with massive chunks of raw data, the agent interacts with the workspace to receive clean, simple reference paths for its compressed payloads.
Next up, Section 4, Managing Multi-Tenant Deployments. Let's look at this at scale.
To handle a huge scale, we introduce the Workspace Manager. If the workspace is the office, the Workspace Manager is the building administrator for our massive skyscraper. Its prime directive is to map incoming requests to the correct workspace and absolutely prevent any data bleeding across different tenants. It takes care of 4 key tasks. Allocation, so creating new workspaces or fetching active ones. Caching and TTL, basically monitoring the system and gracefully evicting idle entries to save compute power. Then there's the isolation policy, which is super critical. It dictates whether workspaces are grouped by specific agents, individual users, or temporary sessions. And finally, cleanup, ensuring the cache is fully drained and resources are properly released when you shut down.
Let's look a bit closer at how the different built-in managers handle that isolation policy.
Both local and E2B use a straightforward agent_ID as their isolation key. But look right there at the DockerWorkspace Manager. It uses a really unique combination of both the user ID and the agent ID. What that means is the host working directory physically separates the data first by the user and then by the specific agent they happen to be interacting with. That level of granular mapping is exactly what makes deploying a truly secure, multi-tenant service possible right out of the box.
And finally, Section 5, the MCP Gateway Solution.
Okay, so here we hit a bit of a roadblock, a seemingly fatal flaw in isolated execution environments. How do MCP clients actually communicate with the host system if platforms like Docker and E2B inherently block standard input and output streams across their boundaries? Remember, for maximum security, the MCP servers are running completely trapped inside the container or the cloud sandbox. The host machine can't just reach in and talk to them using standard I/O. And obviously, if they can't communicate, the agent literally can't use its tools.
Well, AgentScope solves this beautifully with the MCP Gateway. Think of it as a lightweight fast API intercom system installed entirely inside the workspace. It's highly secure, protected by a per-workspace bearer token that gets freshly minted every single time you initialize. Then, on the host machine side, AgentScope uses two very-cover adapters to preserve the standard interface. First, the Gateway MCP client ensures that standard operations like connecting or listing tools are automatically transformed into HTTP requests and sent over to that Gateway intercom. Meanwhile, the Gateway MCP tool takes care of the actual execution by posting directly to a REST endpoint. So to your core agent code, the tools look and behave exactly like local tools, but under the hood they are safely communicating across very strict security boundaries.
We've definitely covered a lot of ground today. We saw how a workspace provides a dedicated office for an agent, how the interface stays identical whether you run locally or up in the cloud, and how the manager and gateway let you securely scale to thousands of users. Which leaves us with this final thought to chew on. How far can you scale your multi-tenant service using dynamic environments in an MCP gateway without rewriting a single line of your core agent code? The framework gives you the ultimate execution environment. What you decide to build inside it is completely up to you. I really hope this explainer has clarified the power of the AgentScope 2.0 workspace. Thanks for learning with me today.